Hi! In this demo video we'll explain the DART challenge as one of the ChainRed success stories. DART stands for Data Accessibility, Reproducibility and Trustworthiness and represents our vision for a complete research cycle. Please note that this is a long technical video. If a gentle introduction is desired, please visit the project webpage for a shorter one. The process will be performed in 3 different steps. First, we'll see how to look and search for data sources. Then, we'll see how to execute experiments on distributed infrastructures, employing this data as the experiment source. And in the end, we'll see how the tools provided by ChainRed's project enhance reproducibility, that is, the ability to reproduce the experiments by different people in different environments. The first step in a research project is to find adequate material. The Chain project webpage includes several tools that can be employed for this sake. The first one is the knowledge base, where the user can explore many document and data repositories. At this moment, about 2,500 open access document repositories and 500 data repositories are integrated in the knowledge base. And all of them can be accessed with just a few clicks. All the information is presented in a table, where results can be filtered to simplify the user's job. And when you have found the desired repository, you can access it with a single mouse click. In this case, a repository on cross-sections of different molecules has been chosen. Being an open access data repository, the user can freely explore it and if desired download the relevant data. Finding relevant information in such a big number of resources can be difficult. That's why ChainRed incorporates the so-called semantic search that allows looking for information in all the repositories at the same time. This information can be of any kind, and the program will search not only on the title of the articles, but inside the abstract and the related metadata. Of course, you can search the paper authors too. And the results will not only be presented as a standard list, but also with a set of relationships among them, which allows to extract new information. The results are ordered according to the ranking web of repositories, ensuring that the most relevant tomes will be presented first. On the result of the search, you can click on any of the elements, and a lot of information about it will be displayed. First, you have the general information about the document or data. Then, you have the information about the repository where it's found. And at last, you have an identifier giving you direct access to the dataset. If the document is presented in Google Scholar, information like the number of citations is retrieved too. As you can see, with this approach it's really easy to search into thousands of repositories and retrieve the desired information with just a few clicks. Any document or data repository can be integrated into ChainRed's knowledge base, only requiring to implement their metadata with the Dublin Core schema and the Open Access Initiative protocol for metadata harvesting. Then we'll see how to execute experiments on distributed infrastructures, employing this data as the experiment source. For this sake, we'll be using the ChainRed Science Gateway. The user is identified with a certificate in his browser. Many different ones are supported. And after that, he can use one from the more than 30 applications which are freely available for researchers. In this case, we'll use the Molon portlet, which employs distributed infrastructures to calculate the molar absorption coefficient from the cross-section. Molon is able to employ the information found in the semantic search as an input data in a completely unattended manner, as well as local file, which will then be uploaded to the system. The jobs are submitted to a grid infrastructure, completely transparent to the user. This is implemented by mapping the user ID to a robot certificate and employing it to submit the tasks to grid infrastructures. This is done by the applications with the employment of SAGA API to connect to a WMS user interface. The status of the jobs being executed is always displayed inside the Science Gateway. A job will go through a number of steps. First, it will be on the submitted step, then on running, and when the experiment is finished, the results are stored and can be downloaded by the user. If the experiment has succeeded, the user may want to ensure its reproducibility. Within the ChainRed's project, we can ensure that the experiment will be easily transmitted to a different researcher and employed in future investigations. To do so, we have created a portlet that allows to create and manage PIDs, that is, persistent identifiers employed to identify the input data of our applications. The PID can then be employed as an input parameter of our portlet, so the experiment can be repeated. And of course, if you have any mechanism to store the output data from the web, you can create a PID of that too, so it can be retrieved with a single click. And what's even better, You can upload your result to an open data repository, ensuring that it will appear next time somebody searches for it in the ChainRed semantic search, contributing to the open global science. And so it's done. Easy, isn't it? In ChainReds, we'll be very happy to adapt Dart workflow to your necessities and use cases, so please feel free to contact us. If you found this video interesting, please come to our homepage and discover what ChainReds can offer you. This project is co-founded by the European Commission under its 7th Framework Programme. Thank you for watching.